Lesson number 83 is about coin problems. And our first problem says, Jack and Betty have 28 coins that are nickels and dimes. If the value of the coins is $1.95, how many coins do they have of each? Now this is a problem where using subscripted variables is very helpful. Because the number of nickels we could call the number of nickels, n sub n, and the number of dimes we could call n sub d, the number of dimes. Now if we use those in order to set up a coin problem, we need to have two equations. The first one tells us how many coins we have. And we know there's 28 coins that are nickels and dimes. So we could write the number of nickels plus the number of dimes is going to be equal to our total of 28. Then we need to have an equation that tells us about money. And nickels, well, if we look at nickels, nickels are going to be worth 5 cents. So if we write that out, we could write 5 cents for the number of nickels. So 5 times the number of nickels plus a dime is worth 10. 10 times the number of dimes is going to give us how much money we have. Now, if this is a whole number and this is a whole number, and they're both in cents, then this also has to be in cents. So that would be equal to 195 cents. And now we can go ahead and solve. And we've got lots of different options here. We can use substitution, we could use graphing to solve it, or we could use elimination. Let's use elimination to solve. And to use elimination to solve, let's multiply this first equation by -10. And that will help us eliminate the number of dimes. So when we do that, we're going to get -10 times the number of nickels plus -10 times the number of dimes is going to equal 28 times -10. That's -280. We'll see if this shows up. That looks good. Then we've got 5 times the number of nickels plus 10 times the number of dimes is going to equal 195. And now we can solve using elimination. When we do that, -10 plus 5 is -5 times the number of nickels. -10 plus 10, that's 0, is going to equal, and then we have -280 plus 195. Well, if we look at that, 280 plus -280 plus 195, well, that must be equal to -85. Now, we can go ahead and continue because we're going to divide. We're going to divide by -5 on both sides. Divide by -5, divide by -5. The -5's cancel, and we have the number of nickels. The number of nickels, good thing it turns out to be a positive number. Number of nickels is going to have to be 17 because 17 times 5 is 85. And we've got our first answer. Now, don't forget to get the number of dimes that you have. We know there's 28 total coins, so the number of dimes, 17 plus 11, is going to equal 28. And we've got the number of dimes. So this is an example where using subscripted variables can be very helpful because it helps you to keep it all in order as to what the number of nickels will be and the number of dimes will be. If you had used X and Y instead, then you would have had to figure out which is the number of nickels and which is the number of dimes. You could have done that, but this way is very efficient. Let's look at another example. Ming has $4.45 in quarters and dimes. She has 8 more quarters than dimes. How many more coins of each type does she have? Now, in this problem, if we're going to go ahead and solve, we've got to write two equations. We know we've got the number of quarters, so let's call that n sub q, and the number of dimes, n sub d. If we write out our first equation, we can call that money because the money comes first. So quarters were 25 cents. So 25 times the number of quarters plus 10 times the number of dimes, because a dime is worth 10 cents, is going to be equal to 445. Next, we've got to go ahead and write out what our equation is going to be for the amount that each of them have. She has 8 more quarters than dimes. So we're going to have to say, in order to figure that out, the number of dimes plus 8 is going to equal the number of quarters, because it says she has 8 more quarters than dimes. So we'd have to add 8 to the number of dimes to get to the number of quarters. Now in this problem, it doesn't set up very well for elimination. It actually sets up really well for substitution. So let's solve with substitution, because we know the number of quarters is right here, the number of dimes plus 8. So we're going to get 25 times the number of quarters, which is the number of dimes plus 8, plus 10 times the number of dimes is going to equal 445. We'll use our distributive property, 25 times the number of dimes plus 200, because 25 times 8, well, 8 quarters must be $2, so 25 times 8 is 200, plus 10 times the number of dimes equals 445. Let's simplify more. The number of dimes, we have 25 and 10. That must be 35. 35 is the number of dimes plus 200 equals 445. Then we'll subtract 200 from both sides. Subtract 200. Subtract 200. And then we can get one step closer to our answer. So if we come up here to work, we're going to get 35 times the number of dimes is going to be equal to 245. 445 minus 200. And then we divide both sides by 35 to find our final answer for the number of dimes. 245 divided by 35? Well, 245 divided by 35, that must be equal to 7. So the number of dimes is equal to 7. We can box that. All we need to do now is figure out the number of quarters. Well, if the number of dimes is 7, 7 plus 8, if we'd had 7 plus 8, that's going to be equal to 15. And we've got our second answer. We can box that one as well. N sub q is equal to 15. We've got our final answer, and we can move on to our next question. The key of these problems is to set up a system of equations where we have one equation that talks about money, and we have one equation that talks about the amount. Then you can use elimination or substitution in order to find both answers. Lesson practice will be on page 343. Make sure you've got your notes complete, and I'll see you during our next class.